Hello students, how are you? You all are doing fine, na? This is our next part of the lesson, light reflection and refraction. Okay, this is going to be part 6 of the lesson. Okay, so in the last video I also told you that this lesson is quite long. Okay, so we are going to have lots of parts of this lesson. Okay, so if I try to explain in one video, things will be a bit short. Okay, and I have to skip lots of things. So it is better we should move slowly, right? You have lots of times. Okay, so don't worry about time. So we should move slowly and we will understand everything. Okay, so this is our next part where we actually start from the parts where we actually ended. Okay, till now in this light lesson, what we have actually discussed? We have discussed the reflection phenomena first. Okay, before that we actually understood what is the concept of light. Right? We understand that light always moves in a straight line. Okay, that is, it is nothing but the rectilinear part. Okay, so what actually happens in case of reflection? What have we understood from reflection? That when a reflection have to occur, the ray comes from one medium. Okay, it incident in a different medium, but it reflects or bounce back to the same medium where it actually comes. Right? That means what? The medium from which actually it comes, again it backs to the same medium and making some angles with the normal. That angles are nothing but the incident angle, the reflected angle, or angle of incidence and angle of reflection, right? So, and there two angles are actually same. There are some reflection raw. Now we will first discuss, right, some phenomena or some observation about, okay, that we actually observe in our day-to-day life. What are those actually phenomena? See, whenever you consider, just consider, this is a glass. Okay, this is a glass. Till here the water is filled. Okay, so first consider that I have actually put a pencil here. Okay, this is a pencil. Okay, have you ever noticed that when you put a pencil inside a glass filled with water, what actually looks, the part under which the actually pencil is, it looks like a bit this. Okay, that means it looks like, if you look from here, okay, if you look from here, it will look like somehow this. But if you look from here, okay, what will it look? That pencil surface has become a little bit upward. Okay, pencil surface has become a little bit upward. That is, the surface looks like here compared to here, right? Again, if you consider one more glass, okay, one more glass, consider one more glass, and it is again filled with water. Okay, it is completely filled. If you drop, or if you actually dip a piece of lemon, okay, consider this as a lemon, the part which is actually inside the water looks like a little bit bigger in size. Okay, looks like a little bit bigger in size compared to the above part, which is actually outside of the water. This is one factor, right? Again, you consider one more example, okay, where it is actually completely filled with water. If consider one letter A, okay, now if I bring this letter A here, it look like bigger in size, right? These are quite facts or quite observation. You can do it in your home. Just do it in your home, then you will observe this thing that what actually I am saying, right? Now, what is the main phenomena, okay, because of this actually things are actually happening? That is nothing but our today's topic, refraction. Okay, this is our today's topic, refraction. Okay, because of this phenomena, all these things are actually happened, or actually happens every day. It's a universal truth. Okay, it have to be same in everywhere, right? So again, what will happen if we consider in place of water some dense particle like kerosene, petrol, like this? What is going to happen? We will actually understand in step by step. Okay, first we have to understand what is the refraction is. Refraction is nothing but the bending of beam, okay, when a ray incident on a certain medium, okay, at the surface of a certain medium, okay, and when after getting incident, when it tries to move through that medium, depending on the nature of the, okay, that medium, it actually move towards or away from the medium. That is the main phenomena which is actually known as the refraction. Okay, so we will see some factors, okay, factors of refraction, right, on which the refraction actually depends, that we actually discuss, right. We are going to consider two cases, right. Again, we are going to use this ray is normal n dash. Okay, these are some normals. Okay, you are going to have two new terms, rarer medium and denser medium. It's not a densing, not that denser, denser. Okay, denser means dense, highly dense, and rarer means little bit less dense. Okay, see, whenever, now first you should understand what is the rarer medium and what is the denser medium. Dense means if I consider this air, okay, it has density. Okay, then if you consider water, is again density. What do you think which is going to have more density? Obviously water, right? Water is having particles very close compared to the air, because air is nothing but what? Gas. There are lots of gases are there. Again, gases are free. Okay, their particles move with higher amount of kinetic energy. Okay, in class 9, their first lesson, matter in our surrounding, you have got that once the kinetic energy increases, it changes its states. Okay, from liquid to gas, from solid to liquid, and liquid to gas, it changes its states once it gets kinetic energy. Okay, that means what? If I consider this amount of area where it is only gas, again if I consider one more area where it is completely filled with liquid, which is going to have a high density, this is going to have, this is going to have high density, right? So this is the fact, because it is in this case the particles are quite close to each other compared to the gas or in the air. So we will consider the rarer medium as the gas. Okay, you can see it is a relative thing. Okay, if it is water, if it is glass is going to have more density compared to water. That means for water, glass is more dense, and for glass, water is rarer medium. Okay, so the concept of rarer and denser medium is quite relative. Relative means what? Depending on the nature of the other particle, our nature. Okay, our nature depending on the other particle. Okay, if I say that I have less money compared to, relative to that guy, that means that guy has more money than me, then I can say I have less money relative to that guy. Okay, so this is the main fact. Okay, now you have understood the concept of rarer and denser medium. Whenever I actually represent the rarer medium as Rm and denser medium as Dm. Okay, whenever a ray comes, okay, and incident on this point, which is the main joining point of the two mediums. Okay, when it moves through the second medium, or it is in medium 1 or the medium 2. Okay, when it moves through the medium 2, what is going to happen? This is the denser medium, so it will move towards the actually normal, but the actual path should look like that, right? Now this is the actual path of this. This should be the actual path actually of this incident ray, right? This incident ray. These are the main factors that depending on the rarer medium and denser medium, it actually behave like differently. Okay, once it comes from the rarer medium to the denser medium, it moves towards the normal. Now what will happen if the rare light actually comes from denser to the rarer medium? Now consider this as the medium 1. Now consider this as the medium 2. Okay, what is going to happen when a ray comes from a denser medium to rarer medium? I can consider this simple ray. It incident on this point, and this is the incident coming from this direction. I will give a cursor like that. Since it has incident on a rarer medium surface, it will move away from the normal. Till now we have actually understood that depending on the medium, okay, from rarer to denser or denser to rarer, the refracted ray behaves differently. Okay, when the incident from a rarer medium and get refracted to the denser medium, the refracted ray, okay, actually move towards the normal. Okay, and in the second case, okay, this is the first case and this is the second case. Consider this as, in the second case, what is actually happening, that when a ray comes from a denser medium and incident on at the interface of the two medium, and it refracts through the rarer medium, the refracted ray moves away from the normal. You have understood till now? You have understood. Now, why this thing is actually happening? Okay, we have understood one thing, that because of density, rarer medium has less density compared to denser medium, and denser medium it is a vice versa thing. Once we discuss refractive index very deeply, okay, then we will understand there is a concept of velocity. Okay, velocity actually applies some factors. Okay, there's a link of velocity with this thing of refraction. Okay, and there will be one more new term, refractive index. You are going to get this. Okay, we will discuss step by step. Okay, this is the main factors of the refraction. Okay, this is how the refraction actually works. This is the main base of the refraction. Okay, now we will move towards one important part of your lesson. This is the refraction through glass slab. Okay, this is going to be a new topic, and this is nothing but the refraction through glass slab. We all have actually watched the glass slab. Okay, you may got some practicals of this refraction through using a glass slab. In 3D figure, it somehow look like that. Okay, this is the glass slab. Okay, this is in 3D motion, it is look like that. Okay, what actually happens in case of a glass, if the light enters like this, okay, it is the rarer medium since it's the air. Okay, outside of that glass is nothing but air, and this is the main glass, and glass have more density compared to the air. So what is the thing? It is the rarer medium. This is the denser medium. Again, it is the rarer medium. Okay, the same thing will appear if it is a normal. This normal should not be like that. Okay, consider this as the normal. Okay, what will happen? This, after getting incident, the refracted ray will move towards the actually refracted normal. Okay, again I will consider here. It is the one more interface. Again consider one more normal here. Since it is the denser medium, it is a rarer medium. What happens actually when it moves from denser to rare? It gets away from the normal. So the refracted ray will move like that. Okay, it's not like that. It should move really like that. That means this incident ray and this ray, after getting refracted, should always be perpendicular. Sorry, not perpendicular, parallel. Now, why these two rays are going to be parallel, we'll understand when we will consider a two-dimensional thing. Okay, this is a glass slab. Give name A, B, C, and D. This is a glass slab. This is a 2D phenomena. This is the 3D actually figure. Now, first we will consider one normal, which is always necessary. In case of reflection, normal is always necessary. This is medium 1. This is the medium 2. Right? And it is the same medium, that's why we will consider two medium, medium 1 and medium 2. And this is air. And this is what? Glass. So from our concept we can say this is the rarer medium and this is the what? Denser medium. So we have understood till now that how actually it works when the ray comes from a rarer to denser medium. What actually happens when a ray comes from a rarer to denser medium, it actually the refracted ray moves towards the normal. Give some name here. This is the point O, this is the point N, and this is the point N dash, right? Same thing. I will erase this O and write it here. Okay. Now consider one incident ray. Okay. This is the incident ray. Okay. And this is the incident angle. Okay. So since it is coming from rarer to denser medium, what will happen? It will move towards the normal. Okay. This is the refracted angle. The angle making with the normal after getting refracted is the refracted angle or angle of refraction, and the angle making the incident ray with the normal is the angle of incidence, right? See, once it again incident here, okay, the refracted ray getting incident here, na? For the second slab, that refracted ray is the incident ray for the second slab, for the second phase. This AB is the first phase, is the main phase AB, and is the opposite phase is the CD. That refracted ray is going to be the incident ray for the second surface. So it will again, I can consider that the refracted ray incident here. Okay, since it is the denser medium and this is the rarer medium, right? So what do you think? What is going to happen? It will actually move away from the normal, because it is a rarer medium, right? This medium is whole medium is a rarer medium, because this is the rarer medium. It again from rarer medium it enters to the denser medium. Again from denser medium it again get out towards the rarer medium. Now each ray has some name. Okay, again it is the angle of, we can say, give name as I, not I actually, it is some angle. Okay, the main fact, right? This angle, do you know what is the angle is known as? First we will say what are the rays. This is the incident ray, we all know. Give some name, A, O, B and C. I'm just giving some names. This OA ray or the AO ray is the incident ray. This OB ray is the nothing but the refracted ray, and this BC ray is known as what? Emergent ray. Okay, that BC is nothing but emergent ray. Okay, and the angle that emergent ray is making with the normal is not the angle of emergence, right? It is represented by E. Now one factor is there. This incident ray and the emergent ray are always parallel. Now you think why? Because this angle of incidence is always equal to the angle of emergence. That is angle of I is equal to angle of E. Angle E. Because why? Same medium. Okay, coming towards the medium, and this from the same medium it is going away to the same medium. It is air, and they for them it is a common actually second medium, right? For the first case, what actually happened, from air to it moved towards the glass, which is a denser medium, and now from glass it again moved towards the rarer medium. So density in this medium and this medium is quite same. So the angle, effect of angle will be same, right? Right now. So this is the fact. See, consider one example that if you are moving in a free road, okay, it is a free road. Okay, consider this is a free road. This is A position, this is B position. Okay, here you have the speed of almost 70 km/h. Okay, if the B position is also free, okay, if there is no traffic, you can also move at the same speed, right? Right now. But in middle, if there is traffic, right, you have to slow down your speed till 30 km/h. That means what we can say, once it enters the traffic, which from with 70 km/h, it have to slow it down, right? Again, it get away from the traffic, again it enters the free road, it again increases speed till 70 km/h. Consider that that car only moves till 70 km/h, right? So this is the quite example how or why the angle of incidence and angle of emergence is equal. Since angle of incidence is equal to the angle of emergence, that's why this incident ray and the emergent ray is always parallel. Okay, this is the main thing about the refraction through glass slab. I hope you have understood the concept. Quite simple. Okay, now we will move towards the next topic. Our next topic is going to be laws of refraction. In case of reflection, we got only two laws. Okay, so in case of refraction 2, there is going to be again two laws. The first law is quite simple to the laws of refraction. First, we will draw one figure. Okay, this is the normal, and this is the medium 1, and this is the medium 2. Also, this is the rarer medium, and this is the denser medium. I'm just considering this. So this is the incident ray, which incident on the interface on where the two mediums are actually joined. Since the denser medium from rarer medium to denser medium actually moves towards the normal. This is the angle of incidence, is the angle of refraction, right? Give them some name. O, this is the O point, A, O, B, N, N dash. I just given some name, and it's the actually PQ surface. Okay. So first law actually says that the PQ surface, right? If you look closely, that normal, right, is quite simple to that laws of reflection. If you consider this as a point, okay, that incident ray incident on this point, okay, and that refracted they refract from that point, and this normal is again on the same point, and where that point is actually lying, the PQ surface. So what we can say, we can say AO, that is the incident ray, that normal, N dash, and the refracted ray OB, okay, lies on the same plane PQ, okay, which is the interface of the two medium, right? Simple. This is the first law. Now what is the second law? What it actually says? It says, the second law actually gives us a ratio, okay? What that law actually says, that the ratio of sine of the angle of incidence to that sine of the angle of refraction is always constant, okay, but for a given pair of media and for a given color, right? So now what is sine? Sine means I think you have got trigonometry. So in trigonometry, or maybe you have not got trigonometry. Once you have got trigonometry, you will understand the concept of sine, cosine, tangent, okay, like that. So sine is nothing but a notation of an angle, okay, so it is like that. So and that sine is actually represented by like this sine. And what is the angle of incidence? I. That means we can write sine I. Okay. What that actually the second law says, that this ratio of sine of angle of incidence, right? Ratio means what? Division of two things, right? That law is actually saying that the sine of angle of incidence to the sine of angle of refraction. R is the refracted angle. So again same thing, sine R. Okay, sine I by sine R is always constant for a given pair of media, okay, and for a given color. But this is constant and this is true for say certain range of angle of incidence and angle of reflection. That angle should be between angle's raise hands 90 degree. That means it should be greater than 90 degree but have to greater than 0 degree but have to be less than 90 degree. So this is the main thing. And for a given pair of media, same media, a pair of media, okay, or for a given color, okay. These are a certain case depending on which this is the truth, okay, this is true. Now when scientists do some experiments, they have found that this is constant, okay, for a given pair of media. Okay, if you consider one more incident ray in the same media, okay, it will again reflect, okay, if the angle of incidence changes, angle of refraction also changes, okay, may get actually move towards or little bit away from the normal. If you consider lots of actually incident angle, and if you take the ratios, that ratio is going to be constant, okay, and this law is nothing but known as the Snell's law, okay, this is nothing but the Snell's law. There may be a question in your exam that define the Snell's law or state the Snell's law. You can get 2 marks. First you have to write down the law, then you have to write this down. This sine I by sine R equal to constant. What this law actually states, that the ratio of sine of angle of incidence to the sine of angle of refraction for a given color or for a given pair of media is always constant. Then you have to write this equation, sine I by sine R is equal to constant, okay, and that constant is actually known as what? Refractive index. Now what is refractive index? So you can ask me, what is refractive index? Our next topic is going to be refractive index. You can ask me questions, sir, what is the refractive index? We are hearing this new term for the first time. I will explain you. Don't worry. I'm here, so never fear. So that new term is known as the refractive index, okay. So if you want to write this down, just pause the video and write this down, okay. So I have actually explained you what is the 2 laws of reflection, okay. So don't get confused with the laws of reflection and the laws of refraction. This one is quite simple or quite similar to reflection and for the refraction, but this is the different one, okay. So now we will move towards the next concept, refractive index. What actually refractive index is, right? We have to understand this. Okay, we have to understand what it is, how it actually works, right? Our next topic is going to be refractive index, right? Refractive index. I will actually represent here by n, and some teachers actually represent it is by nu. Okay, in class 10 we will actually represent this by n. Okay, so don't get confused about that. Consider this as any quantity. Okay, you can represent by any quantity. If you want to represent by some different quantity like p, q, etc., etc., then you have to clearly mention the refractive index equal to, in bracket, s, like that, where you write the s is representing refractive index. Okay, this is the main thing. Now we'll move towards the refractive index. Okay, we have till now actually observed that what happens when a ray incident on a certain interface of the two medium, right, at the conjunction point, the junction of the two medium, okay, and when it tries to move through that medium, what actually happens? It changes its direction, right? This is the junction of the two medium, right? This is the junction of the two. Junction means what? The joining point, right? The resting point for the two medium, right? So this is the junction of the two medium. What is happening? When the ray incident on this certain point at the interface of the second medium, when it tries to move through that medium, it changes its direction. Its original direction was like this. Now this is the original direction. Original, right? But it actually not move through the original part. It just bend down. Okay. Now sometimes when it moves from denser to rare, it will again move away from the original part or the move away from the normal. Okay. This actually happened. But why this actually happened? On which factor? Or right? By which quantity we can actually determine that why this thing is actually happening. That quantity is nothing but the refractive index. So if you ask me, sir, what is actually refractive index is if I have to simply explain you, okay, once you go to the higher classes like higher secondary, master degree, BSc or as like that, you will get it in deep manner. But for now, you should understand the fact that refractive index is nothing but a physical quantity which actually explain, okay, how much the incident ray after getting refracted or that refracted ray is going to change its direction from the original part, or you can say how much that refracted ray going to move towards or away from the normal. This is the fact, or this is the quantity that actually going to define that. Okay, so we have got from the Snell's law that sine I by sine r equal to constant, right? And that constant is also equal to n/1. Now you may ask, sir, what is actually n/1? We know that n represents the refractive index. Now what is that in suffix dash to 1? That it has a simple meaning. n/1 means refractive index. I have actually written shortly Ri for refractive index of medium 2, it is the second medium, with respect to the medium 1, right? This means that the refractive index of this, if you consider the medium 1 and the medium 2, okay, so n/1 gives the refractive index of the medium 2 with respect to medium 1. Okay, I will explain in briefly. Now reversely, if it is n/2, it is going to be refractive index. Okay, refractive index of medium 1 with respect to medium 2. Medium 2. Simple fact. But in your NCERT book, there is one relation is not actually given. There is a relation between n/1 and n/2. Okay, and that relation is nothing but n/1 is equal to, can I explain what is going to be there? 1 by n/2. That means n/1 is the reverse of n/2. Clear? That means if we have represented, so from here we can write, if we have represented n/1 is equal to sine I by sine r, okay, so what will be n/2? Sine r by sine I. because once you reverse, the numerator will be denominator, denominator will be numerator. Okay, this is the main fact. So again, there are certain relations or certain link up of refractive index with other quantity like velocity. Okay, there's a main link up with the refractive index with velocity. Now we will actually explain how the refractive index actually can be determined with the velocity of light. Okay, the main thing is refractive index N21 means refractive index of medium 2 with respect to medium 1, and N12 means refractive index of medium 1 with respect to medium 2, right? Now we will see what is the link of this refractive index with velocities, and which velocity, that velocity of light, right? So we can say N21 have a relation with velocity. Velocity is like that. Velocity of medium 1, that is the ratio of two things, velocity of medium 1 to the velocity of medium 2. Okay, if I represent the medium 1 velocity as the v1 and the velocity of the medium 2 as the v2, okay, this is going to be the relation of N21. Again, we know that N21 is equal to 1 by N12. So what will be there? 1 by v1 by v2. So it will be v2 by v1, right? So simply if you want to write, what you can write from here, it is, we will write velocity, sorry, it should be N12, velocity of medium 2, right, by velocity of medium 1. Now look closely. Okay, look closely in these two relation. It is represented by v1 by v2. It is represented by v2 by v1. Okay. See. And the velocity of light actually. So I actually forgot to write velocity of light. It should be velocity of light. Again, it should be velocity of light. Okay, you should write it down properly. Velocity of light in medium 1 by velocity of light in medium 2. Simply again velocity of light in medium 2 by velocity of light in medium 1. Okay, you just write down correctly. See, now look closely. When we have to calculate the refractive index 2, that means of medium 2, you always give the second, that means the first medium velocity in the numerator and the velocity of the medium 2 in the denominator. Okay, just see, 1 is in the back side, so it will be in the upside. 2 is in the front, so 2 is in with the denominator. Okay, same reverse thing will be here. Since 1 is the upward in the front, so medium 1 velocity will be in the denominator, and 2 is in the back, so the velocity of the medium 2 will be in the numerator, in the upside of the ratio line. So it is quite easy to understand, right? So this is the concept of the refractive index with the velocity of light compared to the from one medium to the other medium. Light, see, the velocity of light, we know the velocity of light as how much? We know the velocity of light as 3 into 10 to the power 8 meter per second, right? And that velocity actually changes from medium to medium. In air, the velocity of light changes in negligible amount. So we will consider the velocity of light in air as equal to the velocity of light in vacuum. Now what is vacuum? Vacuum means there is no density. And density means what? There is no particles. That means what? There is no traffic, right? It is like a traffic free road. The vacuum is like that. But in air, since there is negligible change in the velocity of light, so we will consider the velocity of light in air as same. That is represented by C, nothing but 3 into 10 to the power 8 meter per second. Okay, and this velocity actually changes. Now consider one thing. I have given you one example of car moving in a traffic free road. Then when it enters a traffic, what will happen? See, once you move in a road from moving by a certain point to another point, if the road is free, your velocity will be maybe you are moving in a constant velocity, right? 3 into 10 to the power 8 meter per second, or you consider you are moving at a speed of 80 km per hour. Once you enter a traffic, can you actually move at that certain or at a constant speed? No. What you have to do? You have to slow down your car. That means what? Your velocity is going to change. Okay? if the traffic is uniform, just imagine it actually, you have to just imagine, right, to understand these things. If the traffic is uniform, you are going to move at a different speed, okay, but in a lesser amount of speed. If that 80 km was the high speed, now you have to move at a slow speed, like 30 km per hour. Okay, you will pass through that traffic at 30 km per hour. That means your velocity changes or your speed changes, right? So similar cases here. We consider two main actually medium that is going to need us in this lesson, that is glass and water. Okay, in water, velocity of light in water is going to be, do you know how much? 2.25 into 10 to the power 8 meter per second. Okay, and for glass, velocity in glass, it is almost 2 into 10 to the power 8 meter per second. You can actually calculate this. I will show you how to actually calculate the velocity of water, velocity of light in water and velocity of light in glass. Okay, we can actually calculate. But the thing is, though this power is same, but the main thing is actually changes, but in a little amount. Okay, it in linear, but it also changes. Okay, because in air there is less traffic, right? But in water and glass there is high amount of traffic. Simple fact. Now there's one more concept. Okay, there's one more concept of refractive index. There is when we calculate the refractive index n of a certain medium. Okay, consider the medium 2, 1. Okay, that means the refractive index of the medium 2 with respect to the medium 1. If we calculate the refractive index as velocity of light in air by velocity of light in medium other, that means other medium, right? The velocity of light in air is always represented by what? C. And what does actually C mean? C means constant. Okay, you may ask that, so why the velocity of light in air is always represented by C? You can actually consider that C doesn't mean, it only means constant quantity, right? That means in air, its velocity will remain always constant, C. And velocity of light in a medium, in other medium, I will represent this by phi. That means when we actually represent the refractive index of a medium, depending on the velocity of light in air, because air is the main thing, in air it is same, okay? Then that refractive index is known as the absolute refractive index, because light speed has its absolute value in air. Okay, this is a maximum point. Okay, nothing can move faster than light, so it is going to have the maximum value, right? So depending on this, it will calculate the refractive index of medium 2. So in that case, that refractive index of that medium is always represented by n2. That means of the medium of which we need the refractive index. If we need the refractive index of the medium 2, depending on the medium 1, that is nothing but the air, then we will always represent that is by 2. Okay, if there's one more medium, that is n1, n3 and n5, so on, if simply we can actually write nm. M represents for a medium of which we need the refractive index. Okay, so the definition will be medium m. That means whenever we actually calculate the refractive index of a certain medium, right, by actually through the ratio of the velocity of light in air, right, by the velocity of light in medium, another medium, then we will get the always a approximate, or sorry, not approximate, absolute refractive index. So this refractive index is known as the absolute refractive index. Okay, this is the concept of absolute refractive index. Again, this is a new concept for you. Absolute means what? Perfect, right? So velocity of light in air is always perfect, always constant, so it cannot be changed. So that's why we always represent the refractive index when we compare the velocity of light, air and a medium. Okay, so that actually gives us the absolute refractive index, and it is always represented by C by phi. Phi means velocity of light in different medium, and C means velocity of light in air. Except this condition, okay, except this condition, whenever we try to find a refractive index, okay, except air. Okay, if I try to find out the refractive index of a medium like water and glass, okay, so what is going to happen? If I write N water glass, that means what? This is the water, this is the glass. If I consider N12, consider this as 1, 2, right? So what will actually represent that velocity of light in glass by, okay, by glass, by velocity, sorry, of light in water. Okay, I told you that which comes in the front, it will be in the less, or there is a numerator, so in the denominator, and which comes in the back, it will be in the numerator, right? It's like the same case, N12, what will happen? V2 by V1, right or wrong? Yes. For N21, what was the thing? V1 by V2. See, which is in the front, it is in the upside, which is in the, actually, which is in the back, it is in the upside, which is in the front, it is in the back side. So always remember that. Now, the thing is, whenever we find the refractive index of two medium except air, that refractive index is known as the relative refractive index, because there is no air, and the velocity of velocity of light in glass is different, in water is different, so there is no absolute value, right? So this is a fact. So whenever we actually find the refractive index, okay, or whenever we try to find out the refractive index depending on the two different media, or two given media except air, that refractive index is nothing but the relative refractive index. Relative means what? I told you that when we actually compare two things, okay, when you compare two things or two nature of the two things, that gives us the relative value, right? Once you go in higher class, you are going to get relative velocity, right, given by the Einstein, the relative motion of a certain thing, okay. So that is the principle of relativity. Also lots of things are there actually. Then you will understand the concept of relativity or relative things. So this is the fact about absolute refractive index and the relative refractive index. What is the absolute refractive index? Whenever we try to find out the refractive index of a given media, okay, depending on the medium of that is nothing but the air, okay. So that refractive is nothing but the absolute refractive index, right? This is given by the C by V. C is the velocity of light and V is the velocity of light in that medium. Again, whenever we try to find out the refractive index of a given medium with respect to in another given medium except air, that refractive index is nothing but the relative refractive index. Clear concept? Now we will actually see one thing, that one new term, that is nothing but the optical density. What actually means? We will actually see that. Our next topic is going to be optical density. Okay, see, optical density in your book actually not part of your syllabus. Okay, maybe one more two more question actually comes. What is really optical density means? First, we have actually understood the concept of refractive index, right? So refractive index of different medium is different. Okay, for glass, Ng is equal to, it is almost 1.5. For water, it is almost 1.33, and for diamond, it is almost high. Okay, 2.52. Okay, and for air, it is 1.0003 maybe. So we almost consider it is as 1. Okay, air. So now I will consider certain things. 1, 2. I will just explain very fast what is actually optical density means. These are three different medias, right? These are normals. Consider this as a water, this as glass, and this as diamond. It has refractive index 1.33, it has refractive index 1.5, it is refractive index highest 2.52. And this is air. Air. That means we are going to have absolute refractive index, because we are just comparing the refractive index, or try to find the refractive index comparing with air. That means that is nothing but the absolute refractive index. So I will consider one incident ray, also here incident ray, also here one incident ray. Okay, since it has some less refractive index, it will move little bit bend its from its original path. Okay, it will again bend a little bit, and the nature is almost like that. See, these things are not done by me. Except this kind of refraction, depending on the different media, is found by the scientists. They have did some experiments. Then they have find out sort of like this. Okay. Now what you're actually saying, once the refractive index is getting increasing, right? The refracted ray moving, getting towards the medium, normal. And why that case, from this concept, what we can actually say, that once the refractive index increases, the density of the medium also increases, right? And density means what? The space between if there is more density, that means what? The space between the particles is higher. If there is less density, it is have the distance between the particles is less, right? So air, in case of water, we can consider that particles are a little bit like this. Okay. In case of glass, it is almost like this. But in case of diamond, we can consider that it's quite dense, right? Quite dense. Quite dense like this. There's less space to pass out the ray. This is the concept of optical density, right? What optical density gives us? It gives us the information, okay? How much the refracted ray is capable of to move through the medium in which we are just in which we are actually trying to get the refraction, right? So that is the optical density. Optical density gives. That air is till now we have actually discussed as the the rarer medium, but the correct term is the optically rarer medium, and it is the optically denser medium. I have to write it down properly. This medium compared to this medium is known as the optically denser medium. Okay, and this is known as the optically rarer medium. Okay, this is the concept of optical density. Now, from this, you have actually understood one more thing, that with the increase of refractive index, our density also increases. Okay, and with the increment of the refractive index, the refracted ray moves more towards the actually normal. So this is the concept of the optical density. So till now we have actually discussed what is actually refraction is. Then we have discussed refraction through glass slab. Then before that we have actually discussed the factors on which the refraction actually depends, right? Then we actually discuss the laws of reflection. Then we discuss the refractive index. This is the main physical quantity which actually gives us the information about the refraction or how much is actually bent, okay, from the actually refracted, from the actually normal, okay, away or towards. Then we actually understand the concept of optical density. So in today's class we have discussed these things. In the next class we will actually discuss the later part where we are going to get the lenses, okay, the how the rays actually behave when it actually pass through, or how the refracted ray behaves once it passed through some lenses. Okay, so I will actually discuss. But by the way, this is the time to actually announce the winner's name of the last my quiz competition. My question was, if the magnification has a value of +4, okay, so where the image will form, right? And what is the nature of the image? Since the magnification is +4, right, that means what? The image will be obviously virtual, because we have understood that once the magnification is positive, the image will be virtual, because every quantity, okay, will form in the positive y-axis direction, right? And the -v will be what? Positive, right? So what you can say, if the m is positive, the image will be virtual, right? And once the magnification is negative, okay, what is going to be there? The image will be real, right? So because why? In case of real image, the image height is always towards the negative y-axis direction. So we are going to get a negative term in case of a real image. So this is one factor that we can say from the magnification value, that is a +4. Now one more factor, that where the image will form. Obviously, if the magnification is having a position of almost +4, so what will be the position? V equal to what? 4u, right? Or you can say U equal to 4B or something like that. So you will get a relation. The image will form between pole and focus, right? So lots of students have given the correct answer. Okay, so I think every student have given the correct answer. Okay, so this is the main factor. So I will just announce the names, because if I try to read all of the students' answer, the video will be much longer. So I will just announce the winner's name. Okay, so I will just announce the names from the old comment to the new comment. Okay, so first answer was given by Tamanna Soikia. Okay, after that Sejal Jazodia. After that her name is Bismita Bosumatari. And after that Ankur Bosya, then Harshita Zain, then Kohli Oliman. After that Dikshita Deka. After that Hirakjuti Haloy. After that his name is Subham Aryan Deka. And then Kaushika Ghosh, then Vishal Jyoti Kolita, then Joy Medhi. After that Nikita Deka. After that Himadri Kolita. After that Poonam Parveen, Aditya Singh, Garima Brahma. After that Zerifa Wahid. Then one is Tritish Pritam Das. After that Jutima Brahma, Subh Sharma, Ruhul Amin. Okay, after that his name is Mandip. Okay, I don't need surname. Then after that Ankit Gupta. After that Disha Kolita. So all of these students give me the correct answer. So this is a quite good thing. That means what you have actually understood the concept of magnification of the concave lens, or in case of a concave mirror or the convex mirror, or that means in the case of reflection. Now I will first today write down the today's quiz comparison question. Okay, then you have to answer about the question. Okay, just let me first write down the question, then you will just note it down in your copy. Okay, quiz competition. I will conduct this quiz competition in my every video. Okay, my question is going to be a ray, okay, of light passes from medium 1 to medium 2, right? The incident angle was 120 degree. Okay, the incident angle is 120 degree. So what information about, so what is the information? What information about refraction? Okay, what information about refraction? That means I am asking that if the incident angle was 180 degree, so what information we can take about refraction? Okay, you can write actually what is the information about refraction. So you have to give me the information about the refraction if the incident angle I is 120 degree. Okay, so this is the today's quiz comparison question. Sorry, actually this video has become a little bit bigger because I have to give you some new concept of the light lesson. So watch the video properly, then you will understand the concept of the refraction, because it is a little bit actually difficult or complicated compared to the reflection. Okay, once we move towards the next part of the video, you will get a little bit complication. But if you watch the videos part by part properly, believe me, if you watch the videos properly by part and just don't try to skip it. If you skip something, you will not understand anything. Okay, so watch the video again, then you will try to understand the whole thing. Okay, I will actually meet you in the next video. So till then, bye bye.